Hello, welcome to AP Calculus 3.2 Notes, which is going to cover Rolle's theorem and the mean value theorem. Now, the Rolle's theorem is built upon continuity, just like your intermediate value theorem and your extreme value theorem. So the first part of Rolle's theorem, for it to even apply, or for you to be able to use it, f must be continuous on the closed interval from a to b and differentiable on the open interval from a to b. The way to tell between, or this is the way I remember, the difference between where my interval looks like is that this closed interval starts with a C, continuous starts with a C. Okay, so the open interval has to go with the differentiable. So the first part, in order for you to apply Rolle's theorem, your function has to be continuous on the closed interval, differentiable on the open. Remember, differentiable means no corners, no cusp, no vertical tangents, and no discontinuities. So if your function has that, Rolle's does not apply. Second part of Rolle's, your y coordinate of your first endpoint has to equal the y coordinate of your second endpoint. So f of a has to equal f of b. If that's true, then there's at least one value in between a and b such that your derivative is equal to 0. Okay, and here's some examples. Now it says at least one number. You could have something like this. Okay, this is our A, this is our B. So notice your f of A is equal to your f of B. Because these guys are equal, if you're continuous and differentiable, you have to turn back around to get to your B. So that means there's at least one value where you had to turn around, where that slope of the tangent line is 0, where that slope or that line is horizontal. Now there could be more than one of those points. This other example here, I have my A right here, I have my B right here. Okay, let's stop B right there. Okay, so that's going to be our f of A, f of B. Okay, so it stops right here. If these are equal, it could turn around several times. So in this case, you have 1, 2, 3 points at which your derivative is equal to 0. So if they ask us, does Rolle's apply, or if they ask us, is there a place where the derivative is equal to 0? That's where we're going to use Rolle's. How to apply it? We first have to discuss if f of x is continuous on the closed interval and differentiable on the open interval. If that's true, then we show that f of a equals f of b. If that's true, it applies, and then we go and find those points by finding the first derivative and setting it equal to 0 and solving. So they'll ask us first, does Rolle's apply? If so, find those values. We have to discuss the fact that it's continuous and differentiable. If it's not, Rolle's doesn't apply. We will actually have to write it out. Now, what we have here for our f of x, that is a polynomial, so we know that is continuous everywhere, most certainly in that interval. We also know that a polynomial is nice, smooth curves. There are no corners, cusps, vertical tangents, or discontinuities, so it is differentiable. We must write it out. F of x is continuous on the closed interval and differentiable on the open interval. So check 1, Rolle's is looking good. The second thing we must do is find f of a and f of b. These should equal the same value. When I plug -2 in, I get 8. When I plug in +2, I get 8. Therefore, Rolls applies. And now we get to find those values. First thing we'll do is find the derivative. The derivative of x to the fourth is 4x cubed. The derivative of 2x to the second is 4x to the 1 power. I'm going to set that equal to 0. Factor out what they have in common, which is a 4x. Factor it out, don't divide it away. That's going to give us x squared minus 1, which if I keep factoring, and you need to factor completely, that's going to be x plus 1, x minus 1. I have 3 critical points. Let's not write critical points right there. Let's just write x equals 0, -1, and +1. So these are those 3 values of c that they're looking for. Before you tell them those are the values, please be sure that you check, are all of these values in my interval? If some are and some aren't, please do not list those that are not in the interval. So they asked us to find all the values of c, so I'll put c equals 0, -1, and +1. Although I'm just boxing in the c values, those are the values where we have a 0 for our slope. All of this and this are part of the answer, because without knowing it's continuous on the closed interval, differentiable on the opened, your endpoints give the same y value, you don't know that these are actual high points, low points. Okay. All right, so let's look at this guy right here. First thing we always want to do is look at your continuity and your differentiability. When I look at this, I notice this is a rational function. We have the opportunity to have a 0 in the bottom, which is trouble because that would be a discontinuity. Look at the denominator. I am discontinuous at x equals 0. As long as 0 isn't in our interval, we're fine. But unfortunately, it is in our interval. We're going to write f of x is not continuous on our interval. And therefore, remember, therefore is our 3 triangular dots, and therefore Rolls does not apply. Does not apply. Because Rolls doesn't apply, we don't have to find those c values that Rolls guarantees. Now the mean value theorem, we can shorten that up just like we did the intermediate value theorem as MVT. Don't get that confused with MVP. The mean value theorem starts off very much like Rolls. That's because Rolls is a special case of the mean value theorem. And when we get to the mean value theorem here, you'll understand where that is. What the mean value theorem says is if f is continuous on the closed interval, remember closed starts with a c, continuous starts with a c. So if you're continuous on the closed interval, differentiable on the open interval, then there exists a number c in that interval such that the derivative at that c is equal to f of b minus f of a all over b minus a. This f of b minus f of a divided by b minus a, that looks familiar. That's slope. That is your average rate of change. Or more affectionately known as the slope of the secant line. Well, the derivative, that's your instantaneous rate of change. More affectionately known as your slope of the tangent line. So if you have your A over here, and let's say B is right here. The slope of the line that joins those 2 points, as long as you are continuous and differentiable in between A and B, there has got to be a point somewhere in here where your slope of the tangent line is going to equal that slope of the secant line. That average rate of change is the same as the instantaneous rate of change. Now, the mean value theorem is that broad case. Rolls is a specific case. Rolls is when that slope is equal to 0. So please note, the mean value theorem is the same as Rolls. Rolls is a specific case of the mean value theorem. It's kind of like rectangle square. Square is a rectangle, a special rectangle. So does the mean value theorem apply? If so, find all the values of C. First thing we check, is it continuous and differentiable on our interval? Okay, well, we do have a problem when x is equal to 0, but that's not during our interval. We have to write it out. F of x is continuous on the closed interval and differentiable on the open interval. There aren't any corners, cusps, vertical tangents, discontinuities. We're fine. We do need to find f of b and f of a and the first derivative so that we can complete this. So far we are on our way on the mean value theorem. So let's find f of b, so f of 4 and f of 1. So when we put 4 in for our x's, we are going to get 5 minus 1. Okay, which is our 4. When we put 1 in, we're going to get 5 minus 4, which is 1. Okay. Let's find our derivative now. Let me just do that right here. Well, the derivative of 5 is 0. The derivative of negative 4 over x is 4 over x squared, using our power rule. So using the mean value theorem, we're stating that the derivative, let's choose a different color, the derivative is equal to f of b minus f of a all over b minus a. That's our mean value theorem. So our derivative is 4 over x squared. F of b is 4. F of a is 1, b is 4, a is 1. So 4 over x squared is equal to 1. Go ahead and solve for your x, so go ahead and cross multiply. We have 4 equals x squared. Oops, I'm running out of room. We'll come up here. So that means x is equal to positive 2 and negative 2. Those are the critical points that I find. Now, look up at your interval. My interval is from 1 to 4. So thanks, negative 2, for playing, but we don't need you, can't use you. So the only point in between there is positive 2. That is where your instantaneous rate of change is equal to your average rate of change. For the examples I have left for you. Watch video 2. See you tomorrow.